The annual global consumption of pasta exceeds 16 million tons. To meet this insane demand, Italian factories produce more than 10 billion boxes of spaghetti every year. We'll travel to one of the factories to show you how water, flour, and semolina are turned into pasta. The largest pasta factory in the world, producing 60% of Italian pasta, is located in Italy. This pasta factory covers an area of 100 soccer fields and produces 330,000 tons of pasta a year, enough to cook 3 billion meals. The company is proud of its claim that it can provide food for every person on Earth in just 18 months. This movie will focus on the production of spaghetti, the most popular dry pasta in the world, but will also cover the 110 different varieties of pasta they produce. More than 140 years ago, Barilla began as a small bakery in the heart of Parma. Today, this pasta maker produces more than 10 billion boxes of pasta a year. Every day, 100 tons of pasta are processed in the company's main factory. Barilla's approximately 230 blue boxes are filled with the 12,700 pounds of pasta that each production line produces every hour. Making dry pasta is simple. Just combine water, semolina flour, and durum wheat flour. From this dough, Barilla makes 110 types of pasta, including long strands of spaghetti. The arrival of a remarkable shipment of wheat marks the beginning of the pasta-making process. 150 tons of this vital ingredient are transported by rail in 20 wagons. Each shipment of wheat, coming from different regions of the world, has its own unique characteristics. Careful blending of multiple batches ensures that each packet of pasta has the same flavor. After unloading through the grids, the wheat is quickly moved to temperature-controlled storage bins via underground conveyors. Efficient management of the main ingredient in spaghetti production is ensured by these silos, which have a total capacity of 600,000 tons. 2 huge shipments of wheat arrive at the plant every week. After an 8-hour quality check, the wheat is sent to the next stage of production. In dry pasta production, where only wheat and water are used, the quality of raw materials is critical. Given the daily consumption of more than 1,000 tons of milled flour, the largest mill in Europe was built to accommodate production. The grain is delivered to the mill by conveyors, traveling a distance of 200 meters from the storage facilities. This mill, one of the largest in the world, has 7 floors. Upon arrival, each grain is thoroughly inspected to make sure it meets standards. A system similar to a powerful vacuum cleaner sucks up the grains to analyze their color, moisture, protein content, and weight. A specialized camera analyzes 34,000 grains per second in real time for damage, screening out unsuitable or faded grains. The flavor of the pasta is determined exclusively by the best grains, which are processed into flour before reaching the mill. Pasta made from wheat may contain impurities such as straw, dirt, and pebbles. These impurities are removed thanks to vibrating separators that thoroughly clean the wheat. The grain is then soaked in water for half a day, which prepares it for the next stage, milling. During the milling process, a rotary mill splits the thick outer shell of the grain, releasing the light yellow endosperm. A method of vigorous shaking through a sieve is used to separate the fine semolina from the grain. Semolina is the main ingredient in the production of most types of pasta. This ingredient provides pasta with not only the right structure, but also a distinct wheat flavor, making it ideal for combining with a variety of sauces and additives. The semolina is further purified from impurities by means of a complex machine equipped with a series of filters that become finer and finer. 8 machines are involved in this process, working around the clock every day of the year and processing 34 tons of wheat per hour. The pasta production itself begins with getting the perfect semolina. After grinding, the grits are instantly transported to the production hall, poured into a hopper and sent to a high-speed mixer, where they are mixed with water to create the dough. This equipment is capable of processing 1 to 2 tons of semolina per hour. Avoiding the formation of lumps in the dough is one of the main challenges in pasta production. The key step is to soak the semolina grains in water before adding them to the mixer. The dough is then vibrated until it becomes as smooth as a pillow, achieving a state that is difficult to replicate even for an experienced Italian chef. After 20 minutes of thorough kneading, the dough is ready to be formed into spaghetti. The extrusion or shaping process begins with a thoroughly mixed dough. The dough is pressed through dies with different sized holes that determine the size and shape of the finished pasta. Spaghetti is formed by pushing the dough through narrow, long holes. Extrusion results in long strands of spaghetti. To create a continuous ribbon of pasta more than 1 meter wide, the pasta is cut to size using rotating blades. The use of preservatives is not required as the pasta stays fresh through drying, during which each shape is pierced. In just 1 minute, the machine is capable of producing 83,000 meters of spaghetti, corresponding to 11,000 individual strands, by squeezing the dough through 2 high-pressure mold blocks. The pasta is cut into 65 centimeter long pieces as it moves along a conveyor belt on moving rails. The moisture content of the raw spaghetti is about 30%. Strict adherence to humidity standards is critical to prevent mold growth and ensure a high-quality finished product. The pasta then undergoes a drying stage in machines capable of processing up to 6 tons of product per hour. These huge drying machines work on a principle similar to hanging laundry on a rope to dry. Whereas traditionally, spaghetti was dried for 3 days under the warm summer sun. Modern technology makes it possible to speed up the process. Drying takes place in large metal structures that consume as much electricity as is needed to supply 30,000 households. During the first hour on high heat, the spaghetti loses 10% of its moisture. Then, over the next 9 hours, 3 more heating and drying cycles take place until the optimum moisture level of 12% is reached. This slow and careful process ensures that the spaghetti does not break or become brittle during cooking. The pasta is then cut to the desired size before being sent to the production line. Modern spaghetti is most often produced in 25 cm lengths instead of the traditional 50 cm, making it more convenient for consumers and food preparation. The spaghetti is then sent to a laboratory for a number of tests including al dente, color, thickness, and gluten levels. The pasta is then packaged. A computer accurately determines the exact amount of product in each batch. The spaghetti is rolled down a ramp where a moving container is filled with the exact amount of product. With the ability to increase the speed to 60 bags per minute, the machine is capable of filling 10 4-kg bags in just 1 minute. Translated with www.deepl.com, translator, free version. Each year, about 1 million tons of pasta are selected, packed, boxed, and packaged here for shipment to more than 100 countries around the world. 100 tons of pasta, enough to make 30 million servings, leave this distribution point every day. 65% of this quantity is sent abroad. In all, there are more than 600 different forms of pasta in the world. From the universally known spaghetti and penne to the lesser-known orecchiette and trophy. Now you're in for something special, as we dive into a world of amazing and unforgettable facts that are sure to broaden your horizons. Get ready to learn something new and interesting that will make you look at familiar things in a new way. Don't miss out. Interesting facts. So, first fact. Pasta is often associated with Italy, but its history goes back to ancient China. It is believed that it was the Chinese who started cooking the dough, made from flour and water, thousands of years before Christ. Second fact, the largest pasta was cooked in Poland in 2015. It was lasagna, weighing 2.5 tons. Third, pasta is one of the most popular foods in the world because of its availability, long shelf life, and ease of preparation. Also, pasta contains carbohydrates, which are a major source of energy. They can also be a source of protein, especially if made from durum wheat. It would be interesting to know what new things you have learned about pasta. Pasta is not only a delicious food, but also an amazingly diverse and technologically interesting product. What facts have been the most surprising or enlightening for you? Tell us in the comments what is your favorite type of pasta and why. Give the video a thumbs up and forward it to anyone you think might appreciate it. For more information, subscribe to the channel and turn on alerts. Best wishes! Claiming to be the first robot of its kind, Nature's Pride and equipment manufacturer Silo have created SpeedPacker, an LR1 avocado packing robot. At Nature's Pride's factory in Maasdijk, Netherlands, it can pack 240 avocados per minute across 3 feed streams. Using camera technology, the robot can detect avocados, ensuring accurate and quality picking and positioning. Given the growing demand for avocados, this invention is designed to ensure efficient and ergonomic packaging, as well as improve communication with consumers and growers. This advanced packaging technology took about 2 years to develop and test. The lemon sorting line at Gria L. Leonardi de Santomera uses advanced methods comparable to the most modern lemon processing and sorting plants. The first step in these lines is to empty the containers, and hot water treatment is an optional extra. The lemons are carefully handpicked, then washed, dried, brushed, and finally waxed to ensure they are clean and preserved. After the wax dries, the lemons are selected for careful examination. Sophisticated algorithms measure the size, color, and weight of each lemon, and then select the best ones based on these and other parameters. To ensure that each fruit is perfect for shipment, the procedure is completed with pre-sorting, labeling, automated packing, palletizing, strapping, and tracking. Built for precision, the Textor TS500 round blade slicer is renowned for its ease of use and accuracy. Slices of meat and cheese in all their weighty glory are masterfully produced by this machine. With its revolutionary circular blade technology, it delivers high production volumes with soft slicing. Reducing product waste and ease of cleaning are 2 important aspects of the TS500's design that turn potential downtime into productive hours. Emphasizing easy maintenance and efficient operation, the slicer stands out for its small form, accessible from all sides, and sanitary features. For optimum productivity, cleanliness, and food safety, choose the Sovo Grater Pro 600, an elite egg sorting and packing station. With innovations such as no side impact and a comprehensive CIP, clean-in-place system for optimal cleanliness without disassembly, it can handle up to 216,000 eggs per hour, or 600 cases per hour. It provides full egg traceability, ensuring that each egg can be traced back to its original location, helping to meet various food safety regulations. The design of the system allows for gentle handling of the eggs, resulting in higher yields with less stress. Sustainable and efficient water bottling is the goal of the Kami Complete water bottling line, which includes the Seedel Combi 2006, used by Jordan. Ensuring the beauty and longevity of the bottles while reducing waste and maximizing the use of resources is the main objective of the entire solution. These lines are at the forefront of bottling technology, with a capacity of up to 18,000 bottles per hour for 0.5-liter bottles, and meticulous attention to every step of the process, from blow molding and filling to capping and labeling. The Sidel blow molding machine and the filling monoblock, two critical components, ensure excellent production performance and superior quality. A crab processor built in Canada's Newfoundland region can robotically split crabs in half or remove their legs, and place the meat and shellfish in a tank. The initial goal is to revitalize local processing by sourcing meat locally, but this could help alleviate the shortage of workers in rural areas and take over duties that are currently outsourced. Such technologies could attract a new generation of workers to the industry, which would change rather than eliminate some jobs. Every second apple can be handled by Smart Packer, a robot that quickly packs them. When stacking apples in trays or boxes, their position must be ruddy and perfectly oriented along the stalk and scales, and this is ensured by this device. With a modular design that allows for flexible combinations and a touchscreen for easy operation, this robot is designed to handle fruit gently to preserve its quality. Increase your competitiveness in the market with Novatech SA's Kiwi sorting and packing line, a complete solution for fruit and vegetable processing. By combining washing, sorting, grading, cleaning, weighing, and packing into a single process, it truly amazes. Rather than focusing on increasing the productivity of individual machines, this method aims to create an integrated solution that increases productivity and reduces processing costs. The efficiency of the cake business has been significantly improved thanks to innovative technology. The impressive combination of speed and quality in cake making is demonstrated by the state-of-the-art Unifiller line, which can produce up to 900 cakes per hour. Round cakes can be easily made with this technology, which simplifies the complex process of dusting, filling, assembling, and frosting in a small space. Bakken is another competitor that offers a complete solution for square and round cakes with an emphasis on high-volume production without compromising on quality. Their versatile modular design meets a wide variety of production requirements, making them ideal for the bakery industry and ensuring efficiency and adaptability. In addition, Belshaw introduces the Donut Robot BER, an impressive donut machine that demonstrates how automation can improve efficiency and quality control. To avoid microbial growth prior to primary packaging, Velix Systems' high-speed cheese sorting and packaging line is designed to meet the unique requirements of each cheese plant. The technology incorporates quality control to reject non-conforming products and is designed to minimize waste and damage while preserving the shape and texture of the cheese. Intuitive multilingual user interfaces make it easy to use, and remote support capabilities help keep it online. A state-of-the-art device developed by Merrill, the RoboBatcher Flex uses sophisticated software and robots to optimize the chicken processing process. This significantly reduces labor requirements, maximizing efficiency, productivity, yield, and minimizing wastage. Improved product quality and sanitary conditions result from automated technology that accurately measures and selects chicken parts to load each tray with a predetermined weight. Profitability and productivity are enhanced through full integration with Morel sorting and portioning systems. A groundbreaking robotic kitchen system, developed by Connected Robotics, is setting new standards for the future of cooking. Soba noodles and kakiage are just two of the new dishes that can be prepared automatically through the use of flexible robot arms and sophisticated artificial intelligence algorithms. In an effort to address labor shortages in the restaurant business, the system automates functions other than cooking, including payment processing and dishwashing. Connected Robotics increases kitchen productivity by combining robot control knowledge with deep learning technology. This frees up employees to focus on serving customers and making their dining experience a memorable one.